Have you ever stopped to think that maybe, just maybe, the solution to our biggest design challenges isn't hiding in some high-tech lab, but is actually right outside your window? We're about to dive into how nature, with its billions of years of R&D, is literally giving us the blueprints for our most amazing technology.
Okay, I know, it sounds like the setup to a really weird joke, doesn't it? But stick with me here. These three totally random things from the natural world, they're connected in a way that is, well, it's pretty revolutionary. They've taught us a thing or two about brilliant design. So what's the connection? It's innovation. The bird's beak inspired a quieter, faster high-speed train. The shark's skin, a more fuel-efficient airplane. And that sticky little weed, it inspired a fastener you've probably used today. See, these aren't just bits of nature. They are time-tested, proven solutions just waiting for us to pay attention.
You know, sometimes the biggest breakthroughs aren't planned at all. They're just complete accidents. They don't start with a complex problem, but with a simple observation, maybe even an everyday annoyance that just happens to spark a world-changing idea. And our first story, it starts with exactly that.
Think about the fasteners you use every day. Zippers, buttons, snaps. Now think about another one. I guarantee you've used it thousands of times. Its origin story doesn't begin in a factory or a design lab. Nope. It starts with a guy, his dog, a walk in the Alps, and some really, really clingy plants. So the year is 1941. A Swiss engineer named George de Mestral gets back from a hike and finds his dog and his pants are totally covered in these little burrs. Now, instead of just getting annoyed and pulling them off, he got curious. He put one under a microscope, and what he saw was amazing. The burr was covered in hundreds of tiny, perfect hooks that latched onto the loops in fabric. And that little moment of curiosity, that led to Velcro, a direct copy of nature's own perfect fastener. Okay, so the story of Velcro is a fantastic example of a happy accident. But what happens when we stop waiting for these accidents? What if we start looking for nature's solutions on purpose? Well, that's when we move from a chance discovery to a deliberate, incredibly powerful field of science. And that science is called biomimicry. It's all in the name, really. Bios, life, and mimesis, to imitate. But it's so much more than just copying what something looks like. It's about really understanding the how and the why. How does a leaf capture sunlight so well? Why is a spider's web so ridiculously strong for its weight? This field actively hunts for nature's proven strategies to solve our own problems. I love this quote because it completely reframes how we should think about the natural world. As a model, it's this giant library of ideas we can learn from. As a measure, it sets the gold standard for efficiency and sustainability. And as a mentor, well, it becomes our teacher. It's about shifting our perspective from seeing nature as a warehouse of stuff to plunder to seeing it as a source of deep, deep wisdom. All right, so enough with the theory. Let's see how this actually works out in the real world. We're going to look at a few absolutely incredible examples where engineers, faced with huge challenges, turned to nature and found solutions that were more elegant and more efficient than anything they could have come up with on their own. Our first case takes us to Japan and their famous Shinkansen bullet train. It was an absolute marvel of speed, but it had this one really loud problem. Every time it flew out of a tunnel, the compressed air being pushed in front of it would create this deafening sonic boom. We're talking loud enough to rattle windows and disturb entire neighborhoods. Now, it just so happens that the lead engineer, Iji Nakatsu, was a passionate birdwatcher, and he asked himself a brilliant question. What in nature moves smoothly from one medium to another, say from air to water, with almost no disturbance? The answer? The kingfisher. It dives for fish, slicing from the thin air into the dense water with barely a splash. So his team completely redesigned the nose of the train to mimic the exact shape and proportions of the kingfisher's beak. And the results were, well, they were just stunning. Not only did the sonic boom problem completely vanish, but the new, more aerodynamic train was suddenly 10% faster while using 15% less electricity. Think about that. Nature's design didn't just solve one problem, it made the entire system better. A win-win-win. Okay, next up, let's head to the skies. Airplanes use an absolutely colossal amount of fuel for one main reason: overcoming air friction, or drag. For decades, the thinking was pretty straightforward. To reduce drag, you make surfaces as perfectly smooth as possible, right? Well, nature had a much different and kind of counterintuitive idea.
Researchers looked at one of the undisputed champions of the ocean, the shark. And when you look closely, its skin isn't smooth at all. It's covered in these millions of tiny grooved scales called denticles. These little grooves actually manipulate the flow of water, creating tiny whirlpools that reduce friction and drag. So, inspired by this, Lufthansa developed AeroShark, a special film with millions of these tiny riblets that they stick right onto the airplane. So what's the impact? It's huge. A single plane on a long-haul route can save about 119 tons of jet fuel every year. That's not just a massive cost saving. That also means preventing hundreds of tons of CO2 from being pumped into the atmosphere. Per plane, per year, all from copying the skin of a shark. It's incredible. All right, for our last big example, let's talk about color. Now, most of the colors you and I see every day, our clothes, the paint on our walls, they come from chemical pigments. But nature has a way cooler trick up its sleeve called structural color. Instead of using chemicals to create color, it uses physics to engineer light itself. And the poster child for this is the brilliant, shimmering blue of the morpho butterfly. This quote really nails it. The wings of a morpho butterfly have absolutely no blue pigment in them. Zero. Instead, their surface is covered in these microscopic layered scales that are structured in such a precise way that they only reflect blue light waves back to our eyes. All the other colors pass right through. It's not paint, it's physics. It's an optical illusion engineered by evolution. And this illusion is inspiring a whole technological revolution. We're seeing it in new e-reader screens that work by reflecting ambient light, just like paper, which saves a ton of battery life. There's a fabric called Morphotex that's colored without using a single drop of dye, which is a game changer for water conservation. It's even being used to create anti-counterfeiting features on money, making colors that are almost impossible to fake. Now, those examples are already out there, changing industries as we speak. But believe me, we are just scratching the surface. The next wave of tech inspired by nature is even more mind-bending, stuff that sounds like it's straight out of science fiction. Let's take a quick look at what's coming down the pipe. Get ready for this. NASA is working on grippers based on a gecko's foot to grab space debris without leaving any residue. Scientists are creating smart camouflage that can change color and texture on demand, just like an octopus. Some researchers are even using the natural electrical signals in mushroom roots to pilot simple robots. And we're now brewing synthetic spider silk, a material stronger than steel, in vats, creating a super strong, sustainable alternative to plastics. It's wild. So we've seen the past, the present, and the future of biomimicry. And all the inventions are incredible, for sure. But honestly, the most powerful thing this whole field gives us is a fundamental shift in perspective. It's about more than just finding clever solutions. It's about learning to see the entire world around us with new eyes. And this, right here, is the ultimate takeaway. For every single problem we face as a species, energy, materials, communication, you name it, there is a very good chance that some organism, somewhere, has already spent millions of years perfecting a solution. The genius is literally all around us, just waiting to be noticed. And that brings us right back to you. The next time you're facing a challenge, big or small, or maybe just the next time you're walking outside, look a little closer. This world is a library holding 3.8 billion years of research and development. So, what question will you ask it? What problem are you going to bring to the greatest mentor of all?